I have a function f of x is equal to the cube root of x plus 1. And I want to know its inverse. So how do I go about finding it? Well, we know that a function is a relationship of x to y in a one-to-one manner. The inverse of the function is a relationship of y to x. So the inverse of the function undoes what a function does. So in order to find that, we need to replace x with y and y with x. So let's start with our equation. We have y is equal to the cube root of x plus 1, and our first step is to replace the y with x and the x with y. Let me put that over here. So we have x is equal to the cube root of y plus 1. So we cube both sides, we get x cubed is equal to 1 plus y. Subtract 1 from both sides. We get y is equal to x cubed minus 1. And this is our inverse function. So if we put in an x here and we get some y, if we take that y and put it into this function, we are going to get back this x that we put in to our original function. That's what an inverse does. So let's do two more examples. I have another one that's relatively simple, but it's just set up differently, and then I have one that's a little bit trickier. So we have f of x is equal to 1 over x minus 1, and I want to know its inverse. So again, we start by replacing. It's easier to deal with this in terms of x and y, so I generally like to replace the function notation with y first, and then we trade the x's and the y's. So this would give us x is equal to 1 over y minus 1. Now in order to get y by itself, we're going to have to multiply y minus 1 over to this side, and then divide x over to the other side, and then add 1. So our first step is multiplying y minus 1 over to the other side. And next we divide out x. Y minus 1 is equal to 1 over x, and then we add 1. Y is equal to 1 over x plus 1. And this is the inverse function. I have one more. This one, it's not really more difficult to understand. It's just the algebra that's involved that can be a little bit tricky. So we have f of x is equal to x minus 1 over x minus 3. And I want to know the inverse. So first we replace our y into the equation instead of f of x. And now we switch places. And here we have two x's. And both of these are going to be switched in for y. So we're going to get x is equal to y minus 1 and y minus 3. So everywhere there is an x, it must be replaced by y, even if there is more than one x. So we did that. Now we need to solve for y. And this is a part where it might get tricky for a lot of people, because we have a y dividing another y. So sometimes it might not be apparently obvious how to isolate the y's. What we need to do is multiply this over to the other side, multiply it out, and then get all of the y's on one side. So let me show you what I mean. Our first step is to multiply this, so x times y minus 3 is equal to y minus 1. And now we can't just divide out our x, because if we divide out our x, we're going to have y minus 3 on one side, and we're going to have y minus 1 divided by x over the other side. But we still would have this y over on the other side. This y over on the stranded on the other side. So what we need to do is figure out a way to get all of the y's on one side and then to be able to divide out by something else. And we can do that by distributing this x out. So we get xy minus 3x is equal to y minus 1. And now what we can do is subtract this 3x, or add this 3x over to the other side and subtract this y over to the other side, and we'll have one side of the equation with just y. So we have xy minus y is equal to 3x minus 1. And now we can pull out a y of this equation, because y is a common multiple, or is a common factor. It's a common factor. Y is a common factor, so we can pull out y. So y times x minus 1, and this would give us the same thing if we multiplied y back out, is equal to 3x minus 1. And now we can divide out by x minus 1, and we'll leave us with just y. Y is equal to 3x minus 1 divided by x minus 1. And this is our inverse function.